We have any question from homework in chapter 7? So last time we went over section 7.1 and 7.2. So essentially, we learned that to find the confidence interval for the mean, we need to compute the margin of error. The margin of error is, if sigma is known, the margin of error is z alpha over 2 sigma over square root of n. And if sigma is unknown, the margin of error is c alpha over 2 sigma over square root of n with degree of freedom n minus 1. You are using this degree of freedom when you are using the table at the back of your book. The actual degree of freedom is not always this one, but to understand the table that you have at the back of your book, you will use this degree of freedom. So for the minimum sample size, we learned that the minimum sample size when the margin of error is known is z alpha over 2 times sigma over e squared. Recall that you can always check this one from your book, from the table at the back of your book. You have the values for z alpha over 2. 4.80, you have 1.28. 0.90, you have 1.645. 0.95, you have 1.96. 0.98, you have 2.33. 0.99, you have 2.58. So by practicing, if you are not using the calculator, you can find a confidence interval like this, but you need to know this formula to find the minimum sample size. So today we want to learn about confidence interval for proportion. So we define the sample proportion in section 6.4 as p hat when x is the number of success. So essentially, sample proportion x is the sample size, is the number of success. And n is the sample size. Then the sample proportion is p hat equal to x over n. For example, if you want the proportion of female in the class, we can count the number of people in the class, it has n, and the number of female in the class, that will be x, and the proportion will be x over n. So in 6.4, we learned that the sample proportion, was a good estimate for the population proportion. Proportion is the probability of success. So we call it P. And the probability of failure we know is Q equals to 1 minus P. Is Q. The probability of failure, we write it as Q plus 1 minus P. So in the same way, we can define the proportion of failure, the sample proportion of failure is Q hat equal to 1 minus P hat. So that is the sample proportion of failure. So in most of what we are going to be doing, we are going to use this sample proportion as an estimate of the population proportion. So the next thing we want to figure out is sampling proportion of sample mean. What is its mean? Because we are going to be dealing with estimating population proportion using the sample proportion. So E of P hat is equal to P. E of P hat is equal to P. I think we explained that in 6.4. And the variance of P hat is equal to PQ over N. So that the standard error of estimate for the sample proportion is square root of PQ over N. Now, under what condition do we have a normal distribution of sample proportion? So for the sample mean, we say when N is at least 30, sample mean is approximately normal. For sample proportion, we are going to say that if N times P is equal to 5, N times Q is greater than or equal to 5, then P hat is approximately normal. With mean P and standard deviation square root of PQ over N. N is the sample size or the number of trials. It's approximately normal, and the margin of error for the confidence interval you can figure this out knowing the standard error of estimate is Z alpha over 2 times the standard error of the estimate. C equal to Z alpha over 2 times square root over N. And the confidence interval is P hat minus P hat. Yes. We will have to determine if we can use a normal distribution for the confidence interval for proportion by checking if the number of success is greater than or equals to 5 and the number of failure is greater than or equals to 5. Look, P hat is X over N, X equals to NP hat. We want this to be greater than or equals to 5, which is the number of success. Q hat is N minus X over N. That is, if x is the number of success, n minus x is the number of failure. And this n minus x is nq hat. So when you are asked to determine if a sample proportion is approximately normal, you just need to know is the number of success and the number of failures, both at least 5. When that works, I'm just repeating what I have there. E equal to z alpha over 2. Now we use P hat Q hat. Because we want to approximate P that we don't know, we are going to use the sample proportion for the population proportion. So I have reproduced here the conditions that we can use to check if the sample proportion is approximately normal. So because we don't know the population proportion which eventually we want to get, we use the sample proportion as an estimate of the population proportion. So think about, as we are going through so many elections, you hear polls that give us the proportion of individuals in a sample that are in favor of a candidate. That is a point estimate. That is the sample proportion. If in addition, you are given the margin of error, generally, sometimes they tell you the margin of error is 3 or 4. Sometimes they say plus or minus 3, plus or minus 4. That margin of error will help you to determine the confidence interval for the true proportion of the whole population in favor of that candidate. But the underlying information that we don't have is, was the sample representative of the population? All of this is valuable if the sample is well taken, if the sample is a good random sample. Let's look at an example. So in your textbook, there was an example at the beginning to illustrate proportion. We are saying we will go back to that. Suppose that 800 students were selected at random from a student body of 20,000 and given shots to prevent a certain type of flu. Here we want to test the reliability of a flu vaccine. So what is the actual proportion of individuals that will be immune by taking the vaccine? So 20,000 students is the population. And out of this population, we are going to randomly select 800 of them were exposed to the flu and 600 did not get the flu. So in this case, what is the sample size? What is the sample size? The sample size is 800. And what is the number of success? What is the number of success? 600. What do you think should be the number of failure? Pardon? 200. Both numbers 600 and 200 are above 5. So we can use a normal approximation to estimate the population proportion. The sample proportion P hat is 600 over 800, which is 6 over 8 equals to 3 over 4. And Q hat equals to 1 over 4. So what is the point estimate for the population proportion or the probability of success. What is the point estimate? What is the point estimate for the population proportion? For each parameter, there is a corresponding statistics that is called the point estimate for that parameter. For the population proportion, what point estimate should we use? What do you think? Parameter is for population. Statistic is for sample. For the population proportion, what sample should we use? We use the sample proportion. This is a very simple question, but we want to know the simple ones. When estimate for population proportion is sample proportion. When estimate for population mean is what? Sample mean. That is the statistic we can use to project the population, the parameter. Okay? Not a big deal. So we have checked the requirement here. Find a 99% confidence interval for P. We want to find the 99% confidence for P. Equals to 99% Z alpha over 2. For C equals to 99, what is Z alpha over 2? 2.58. If you practice, you are going to know what it is. So the margin of error is E equals to Z alpha times square root P hat Q hat over N, which is 2.58 times square root of 0.75 times 25 divided by 800. Can you use your calculator to compute this? Point 0.75 times 0.25 over 800. Take the square root and multiply it by 2.58. Anybody has an answer? Point 039. So that is the margin of error. So the confidence interval will be P hat minus E, P hat plus E. That is 0.75 minus 0.0395 less than or equals to P, less than or equals to 0.75 plus 0.0395. So we have 0.71 to 0.79. So p hat equal to 600 over 800 equal to 0.75. And the margin of error is p hat minus f to p, which is 0.75 minus 0.0395, to the net of 0.75 plus 0.0395, so which is 0.71, 0.79. We can use the calculator to do this. I want you to do first how to do it manually without calculator. So you can figure that out by following what we have been doing so far. Everybody can go to start. You go to start. Yes. Z proportion interval. Has anyone seen Z proportion interval in the calculator or something similar to that? Number 5. What is number 5? Okay. Proportion Z interval, number 5. One proportion Z interval. So everybody's okay with calculator? Anybody has a problem using calculator? Let me know if your calculator have an issue, if you don't know how to get to something. When you are in class, I can always help. Okay, the next thing as we did for the population mean is to estimate the sample size required to achieve a certain margin of error. So what is the minimum sample size what is the minimum sample size for proportion? So we will start with an estimate of the population proportion is known as P. Then the minimum sample size is N equals to PQ Z alpha over E squared. You are given from past experience an estimate for the population proportion in the situation in which you are. Otherwise here means if there is no estimate, of E, then will be Z alpha over 2. Kind of you take P equals to half. So this is obtained for those who like understanding the mathematics. This is obtained from here. Because if you don't have, this was the original formula. We replaced by P hat, Q hat because we have P hat and Q hat as an estimate for the population proportion, which we use to make an estimate for the actual proportion that we don't know. So, if we have this, we can solve for square root of n. Square root of n will be Z alpha over 2 divided by E times square root of PQ. And if you take the square both sides, you will have n equals to, I will write PQ first, Z alpha over 2 over E squared. So if P is unknown, use P equals to half. That's essentially what I'm trying to say. But there is a mathematical explanation for that, which you may see at homework. I didn't give you, but if you look in your book, you will see a homework problem that tells you the rationale behind the fact that we use P equals to half. So an n will be 1 over 4, Z alpha over 2. Look at an example. The company is in the business of selling wholesale popcorn to grocery stores. The company buys directly from farmers. A buyer for the company is examining a large amount of corn from a certain farm. So before you buy it, you want to try to determine if it is actually good for business. Popcorn will be good for business if it can actually pop. You don't want to package all your popcorn and sell and people return it. None of it is popping, right? So you want to know, is it good? You want to determine the proportion of the corn that will actually pop. So the question is, what quantity should you buy? You can buy a very large bag of it, but you might not want to spend too much money just to try and fail. You might buy very small, and it might not give you an accurate result. So you might want to know, what is the minimum proportion size I should purchase? So here, the buyer want to be 95% sure that point estimate P hat for P will be in error by either way less than 0.01. That will mean here that the maximum error of estimate is what? What is the maximum error he can admit for his purpose? What is E? C is equal to 0.95. He does not want to be wrong by more than what? More than 1%. 0.01, do we all see where we get that information? So let's start with if there is no estimate, that is, he has never bought corn from this farmer, and he has not been able to find information from people that would have bought from this farmer in the past. So no previous estimate. So we are going to choose P equals to 1/2. Then Z alpha over 2 is 1.96. N will be 1/4, that is 1/2 times 1/2, 1.96 over 0.01 square, which is 196 square divided by 4. You can use your calculator to get this. So here, you want to be 95% confident that the sample proportion he is getting is not more than 1% above the actual proportion that he doesn't know. He may never know. So we have C equals to 95, P alpha 2, 1.96, and E equals to 0.01. No previous estimate of P. You have N equals to 1/4, 1.96 over 0.01 square. So what do we get? N equals to what? 196 square divided by 4. Yes. 9,604. This is the minimum number of corn he should purchase if he want to be right by not more than 0.01. Let's get back to the problem. And see if when this table comes here again, there are several, it comes several times in your PowerPoint. You can get use of it. What is Z alpha for a confidence level? So second part, a preliminary study showed that P was approximately 0.86. If the buyer uses the results of the preliminary study, how large a sample should he use? The preliminary study shows that P equals to 0.86. So P equals to 0.86. What should be Q? 0.14. So PQ equals to 0.86 times 0.14. And we are getting that N equals to 0.86 times 0.14. And the same thing, 196 squared. 196 squared is this quantity, 1.96 divided by 0.01. It's like multiplying by 100. So what do we get here? This is equal to 4625.29. So we can compute the confidence interval using the calculator. For the sample size, we need to use the formula. We still need a calculator, but not like going to start and test. Any questions so far about confidence interval for proportion? So we go to the last section of this chapter. Estimating the difference between the means and the proportions. In doing this estimate, we will use calculator. I'm not going to do a lot of computation here because you already know what those computations are about. So we are going to use calculator to do it. At the same time, to save time. So when we have two population parameters that we want to compare, we want to make sure that the samples that we use are independent of each other. Because we were only able to discuss independent random variable when we were dealing with the standard deviation and the variance. Remember when we have two random variables? I mentioned it, but you did not feel it because there was no situation where they are not assumed to be independent. Because of independence, we will want the sample to be independent for the random variable that are representing them to be used. So we say that two samples are independent if their values cannot be paired. Like, suppose I want to determine if left foot and right foot are not the same for individuals in general. So for that kind of problem, I will take samples of left foot and right foot. Do you think the sample I get should be dependent or independent? What do you think? Should the sample I get in my intention of comparing left and right foot of individual be considered dependent or independent? Maybe you cannot say that, but I will explain what is dependent and independent. So if I take all the left foot for people and take all the right foot, take the sample mean on both sides, do you think it's reasonable to compare the two numbers to determine if left foot and right foot are the same? Do you see what I'm trying to say? When we say left foot and right foot, it should be for the same individual, because my left foot can be 6 and my right foot is 6.5. And somebody else left foot is 6.5 and right foot is 7. If you separate them and take, it means left foot and right foot are the same. Do we get what I'm saying here? So we consider sample to be dependent if they are taken in pairs from the same individual. If you don't need that, for example, if I just want to compare two methods of teaching, I teach in one method, I teach another class in another method, they will be independent. There are many situations where we have independent samples. When we have independent samples, we can compare them. Recall, I will write and erase it. Recall that we say if we have two random variables, x1 and x2, then the variance of x1 plus x2 was what? Variance of x1 plus variance of x2. What about the variance of x1 minus x2? What was it? Anybody remember? Variance of x1 minus x2. It is the same. Variance of x1 Do we write plus or minus here? This is what I'm checking. Should we say plus -1 square, right? And it turns out to be, we can only do this if x1 and x2 are independent. So what is the standard deviation of x1 minus x2? It is the square root of, let me put sigma 1 square, sigma 2 square. So you don't really need to write all this. If you understand it, that's enough. Because I don't question you about it. So there is something I want to get into. That is why I'm doing that. So I'm going to erase this and now use 2 mean. So if we have two samples, x1 and x2, the mean of x1 minus x2 bar, the mean goes to the respective sign. The difference of the mean of the difference is the difference of the mean. Now, if I want the variance of x1 bar minus x2 bar, what will I get? Variance of x1 bar is variance of x2 bar if the samples are independent. So the standard deviation of the difference is sigma 1 square over n1, because the standard deviation of x1 bar is sigma 1 over n1. So sigma 2 square over n2 square over n2. So what are we learning from here? That if we have two populations and we want to compare their mean, we can use the difference of their sample means as our point estimate. Point estimate will be the difference of the sample mean. Okay? So the margin of error will be, and the last expression is what we call the standard error of estimate. That is for the difference. For a single one, it was sigma square over n square root, and it gave us sigma over square root of n. For a single one, the variance of x bar was square root of sigma square over n, which was sigma over square root of n. But when we take the difference, it is now sigma 1 square n1 plus sigma 2 square over n2. So E will be z alpha over 2 square root of sigma 1 square over n1. So we are going to also say if the sigma are none, we use the z distribution as we are doing now. If the sigma are unknown, we use the t distribution with degree of freedom. When you are copying what I am writing roughly, do you understand later? Because I'm just writing numbers and I'm just talking. All of the writing is on the PowerPoint. I do this explanation with writing because I want to, I'm just writing the mathematics, but I am saying, so if you look, I just want you to see where you can go and get more knowledge about it. I'm just avoiding to read the PowerPoint. Do you like when we just go over the PowerPoint and you are seeing it? There is a lot to, for the little I have just said in 10 minutes, you will read a lot more PowerPoint because that is formal. But I try to make it in a simple language when I am teaching. So, but if you want, you go to the PowerPoint and you will read dependent, independent samples. And this is the formula for the margin of error when sigma is known. Z alpha over 2, I like alpha over 2 so that you know that is the value of the tail. So when the population are normally distributed, you have it here as well. When the population are normally distributed, or the sample size for both samples are at least 30, you can assume that the sampling distribution of the difference of sample mean will be approximately normal. So we can use the Z distribution. We use the Z distribution if sigma is none. And if sigma is unknown, we use the T distribution. Let's do an example. In the summer of 1988, Yellowstone National Park had some major fires that destroyed a large tract of old timber near many famous trout streams. Fishermen were concerned about the long-term effect of the fires on these streams. However, biologists claim that the new meadows that would spring up under dead trees would produce a lot more insects, which would in turn mean better fishing in the years ahead. Guide services registered with the park provided data about the daily catch for fishermen over many years. So there was fire, fishermen are concerned, are we going to have more fish, or the fish are going to be afraid of the fire and leave the streams? So biologists are telling them, no, that's not going to happen. In the opposite, there will be a lot of insects that will come up and fish will grow more, and there will be more population of fish. So the problem we will face here is we are going to check if the number of fish they were catching in average before the fire is less or more than what happened after the fire. I'm not reading everything. So now we have information. So from records, a random sample of 167 reports from the period before the fire showed that the average catch was X1 equals to 5.2. So L1 equals to 167. This is the sample size. X1 bar equals to 5.2. I assume that the standard deviation of daily catch per fisherman during this period was sigma 1 equals to 1.9. Second, N2 equals to 125. 5 years later, X2 equals to 6.8, and sigma 2 equals to 2.3. Can we conclude from this information that there was better fishing after the fire than before the fire? What do you think? Is this information enough for us to conclude that fire has improved fishing? Any suggestion? You should think, just say something. It could be wrong, there's no problem. The number before the fire was 5.2, and after the fire is 6.3, from a sample of 167 before and 125 after. What do you think? Are fishermen getting more fish before or after the fire? Before? Before was 5.2, after is 6.8. Okay. Okay. So this is why we do estimation, because we cannot tell now. We cannot tell whether this difference is significant. Do we understand what I'm saying? We need to find that the estimate of the difference between the two before we conclude. So that is why some people, when they see the results of the poll, they just feel one is doing better than the other. They don't care to know what are the margin of error. So, to find the exact difference, we will use a confidence interval or proportion. Do we care to know with this sample size whether the population is normal or not? When the sample sizes are at least 30, we just go ahead for the conditions that we need. So next, we want to find the confidence interval. We can feel free to use the Z distribution because the sigma are provided. What we are interested on is the confidence interval for the difference of the two parameters. So we are using C to be 0.95. So we are going to have E is equal to Z. You don't really need to write this. Over sigma 1 squared over N1 plus sigma 2 squared over N2. We don't have time to do this because we want to learn more. We will use calculator. So are we ready with our calculator? On the PowerPoint, you will see how to do it manually without a programmable calculator. So we go to test. I'm sorry, you know how to go to test, right? You do start, test, I think look at the list that is there. You will see 2Z interval or 2 interval Z or something like that. Can somebody check? Probably after 8, yes. 2 sample Z interval. Sample Z interval. Can somebody tell us why we are using the Z distribution instead of the T here? Anybody knows what we are using the Z instead of T? Because, yes, because we know sigma. Because we know sigma, we are going to need this all through. We will come back to it in chapter 8 because we know sigma. If you know sigma, use Z. Otherwise, use T. Any question when you are using your calculator? With calculator, you will want to choose statistics because you don't have to use data when you enter values in L1 and L2. So having this, if you have a question, let me know. What is the confidence interval? Anybody has something before we check? Anybody has an answer? Anybody have trouble going through? Yes. Yes. Okay. So that is the confidence interval. Now with this confidence interval, we are kind of, this is an abuse of language. We are 95% confident. I told you exactly what it means, right? 95% confidence level means of all the intervals, 95% of them content. So that the difference of population is between negative 2.1 and negative 1.1. So now we look at this difference. Is it a positive difference or a negative difference? Based on this, do you think that that difference is positive or negative? What do you think? Please somebody look and tell me. Do you think the number between -2 and -1 is positive or negative? Do you know what positive negative numbers means, right? So is this number positive or negative? It's negative because it's less than -1. Any number less than a negative number is negative, isn't it? And any number bigger than a positive number is positive, right? So to know whether it is negative, look at the bigger number. If it is less than a negative number, or let me just put, if both numbers are negative, it is negative. If both numbers are positive, it is positive. If the lower one is negative and the upper one is positive, because it cannot be otherwise, right? You can't say a negative number, a positive number is less than a negative number. You can't have positive before negative. So either both are negative or both are positive. With those cases, we can conclude that mu1 minus mu2 is less than 0. Let me write it here. So we have negative 2.10 is less than mu1 minus mu2 negative 1.10. So mu1 minus mu2 is less than 0, right? Mu1 minus mu2 is less than 0. That is, mu1 is less than mu2. Mu1 is less than mu2. So the average before the fire is less than the average after the fire. Now we are right. And we have a good argument to support our conclusion. Before is less than after. So fire has improved fishing. Can we say that? Fire has improved fishing with a statistical evidence. The next thing we want to learn is, when do we use the T distribution? If sigma 1 or sigma 2 are unknown, we use the T distribution of freedom to the minimum of n1 minus 1, n2 minus 1. Because we are using calculator, this degree of freedom is no more going to be that what we have on calculator, because calculator is good calculation. But this degree of freedom is useful when you are using the table at the back. So the margin of error E is T alpha over 2, square root of S1 squared over N1 is S2 squared over N2. So let's look at an example here. Example. Alexander Boboli is a professor at the medical school of the University of Zurich, where he is director of the sleep laboratory. Dr. Boboli and his colleagues are experts in sleep, dreams, and sleep disorder. In his book, Secret of Sleep, Dr. Boboli discusses brain waves which are measured in hertz, the number of oscillations per second. Rapid brain waves are in the range of 16 to 25x. Slow brain waves are in the range of 4 to 8x. All of these are not very important, but what do we want? During normal sleep, a person's cycles will vary and all of that. In one study, a number of subjects were given half liters of red wine before they went to sleep. We want to check here whether alcohol is a good sleeping aid. So we will test. I just want to say it instead of us going through all of that. We want us to finish this chapter today. So it's not difficult. We are just going to use calculator. So he wants to test if sleep can help, if alcohol actually help people to sleep. And he gives half liter of alcohol before sleep to a group of subjects, and the other group, they don't take alcohol. Now we are going to compare the waves. Towards morning between 4 and 6 a.m., the people who took alcohol tended to wake up and have trouble going back to sleep. Suppose that a random sample of 29 college students was randomly divided into two groups. In groups 1, you know, in Germany, they don't have drinking age. So for us, we have to add those students are at least 21. Let's say I told you to drink alcohol when you are not yet 21. So the first group, N1 is 15, and the second group, N2 is 14 people. Everyone in both groups went to sleep at 11 p.m. And the average brainwave activity was determined for each individual in the group. So we have this result. We will have the statistics. Do you want us to try using data? Anybody want to use data, or we should just use statistics? If somebody say yes, we use data. If nobody says in the next 1 second, then we use statistics. Okay. So if you are using data, you enter this data in L1 and enter the next one in L2. You understand what I mean here? You want to save time. When you go home, enter the data in L1 and in L2, and then you will choose data. Otherwise, you are going to use the statistics. What does the statistic tell us here? What is N1? It was on the previous slide anyway. N1 is 15. What is X1 bar? X1 bar. 19.65, and S1, 1.86. And what is N2? X2 bar, 6.59. And S2? 1.9. So we want to compare mu1 and mu2. We will find the confidence interval and check the sign of the interval to determine if it is negative or positive, and then decide if mu1 is less than mu2 or not. Can we use calculator? So you go to start test, two sample, Z interval. If we had entered data, we will choose data. We will still use statistics because we have the statistics. Use your calculator. Remember, N1 equals to 15. It's not here. It's on the other slide. We are using the T, okay? Two sample T interval. T, yes. For the confidence, 90%. We are choosing this so that we just be on the same page. T interval. Confidence level, 90. Yes. If the samples are, okay, no. We are skipping that one. Full is if you have the information that even though the population standard deviation are not known, they are known to be equal. So then you are going to use a full standard deviation, which is, we will skip that, okay? Maybe if we have time, I can explain that, but I don't generally give you problem with full data. Pardon? Yes. So you do start, go back to
It's 0.
choose 2.
It's 0.
It's not test, it's interval.
Yeah, but when you go down over to 10, it's,
No, you are using test instead of interval.
yeah,
We are using interval. You are done. What do you want?
No, I was trying to help.
Oh, sorry. You got it?
Yes.
Everybody has it? What is the confidence interval? You don't like saying it. And because you are not sure, right? You should be sure of what you are doing. What is the confidence interval? 11.86. Okay, no problem. We are not going to get with the T distribution, you are going to get some difference with me because I'm using the T distribution table. You know, table only has some basic. So the answers are not exactly going to be the same, even with your book, but if you are close to it, that will be fine. Is it a positive or a negative interval? It's a positive interval. So mu1 minus mu2 is greater than 0. So mu1 is greater than mu2, meaning that those who took alcohol have their wave, the wave is bigger than those who did not take alcohol. So they were not sleeping. Alcohol just helps you think that you are sleeping when actually you are not. The last one is proportion. What you are going to do for proportion is just go to calculator. It's essentially what I'm going to say is that if N1P1 is greater than 5, N1Q1 is greater than 5, N2Q2 is greater than 5, N2P2 is greater than 5, then you can use the normal distribution. Okay. I would advise you to go over here and read PowerPoint. There is nothing much that I will have to tell you. It is what will be E G alpha over 2 square root of P1 Q1 over N1 plus P2 Q2 over N2. That is E. And you do P hat 1 minus P2 minus E, P, and then you do P1 minus P2. This is the point estimate minus E, P1 minus P2. It's exactly the same thing, but we change mu to P. Let's look at the example here. Based on a study of over 650 people in the Zurich Sleep Laboratory, it was found that about 1/3 of all dreams contains feeling of fear, anxiety, and aggression. So the question is, do the moods that you have before you go to sleep actually determine whether you will have a nightmare or not? So two groups of students are separated, and in one group, they are encouraged to watch comedy before sleep. Comedy will help them have a better mood before they go to sleep. And the other group, they just go to sleep. And we will calculate the proportion of students that watch the comedy and the proportion that did not watch the comedy. So we will have N1, those who watch comedy. This there, N1 is my X1. R for me is X, because that's what you have on your calculator. N2 equals to 180 and X2 equals to 62. So P1 hat is 49 over 175. P2 hat, it is 63 over 180. I hope you understand where they are getting the proportion for each sample. So, we can use calculator now. C is 95%. If you have a question about using your calculator, let me know. Can you use your calculator? Something, start, test, 2 sample Z proportion, 2 proportion Z interval, or something like that. I want you to get used to what you can do it on your own. You will see that interval, 2 interval. When you see 2 an interval, that's the right one. Anybody has it? If you have questions, let me know. Don't mind the fact that I'm rushing it. Because if you do this, we are done. Yes. You don't really need p hat and. This is 2 samples. Proportion Z test. Two proportion Z interval. You are looking for 2 proportion Z interval. 2 proportion Z interval. Has anybody succeeded? Good. Can you just give yourself 1 minute to check if we got the right answer? What do you have? Anybody has this answer? 2 proportion Z interval. Is this interval positive or negative? Is it positive or negative? Is it positive or negative? Neither, right? It's not positive, it's not negative, meaning that it can be 0. Very important. You will get that something like that on your test. So if it can be 0, we cannot conclude whether the proportion, whether comedy actually reduce nightmare. Maybe the question should be, does comedy really give you a good mood? So that's what research is about. When people say trust science, you have to be careful because you need to trust first that comedy will make people to have a good mood. Somebody should do that first. But the conclusion will be here that comedy does not have to avoid nightmare. But they will say your mood is not necessary. We have test and interval. We are doing interval now. From next week, we will start with test. You are free to go if you have Sorry for this. When I leave this small part, I will come back without what you'll be writing what's in that. But essentially, do your homework so that on Tuesday, if you have questions, we will learn better with the questions that you will have. Okay, we are done. You're welcome. You're welcome. Thank you.